Dear friends, this is lecture number 5 of mole concept or some basic concepts. Here today we have to study ideal gas equation. We have to study today ideal gas equation, most popularly that is known as PV is equal to nRT. So friends, before studying the ideal gas equation, we should also study what is the meaning of the ideal gas. Dear friends, suppose that we take the gas in a container. These are the molecules of the gas. Dear friends, for the ideal gas, there should be no any attraction or repulsion force between the particles or the molecules of the gas. No attraction or repulsion force between particles or molecules of gas. So for the ideality, this is the first condition, and the second condition is the volume, the volume of the particles of the gas should be negligible. You can say negligible volume of gas particles, or we can say gas molecules. Dear friends, there is no any gas which is ideal, so you can't say that particular gas is ideal. Naturally occurring gas, there is no any gas which follow these two concepts. Although there are many concepts, we will study to that in the states of matter, gaseous state. But here in this chapter, we have to know little the introduction of the ideal gas. So there is no gas, no ideal gas, no gas is ideal. So dear friends, we will assume that all the given gases are ideal. All given gases are ideal. We have to treat for the simplification of our calculations that each and every gas given that is ideal. So until otherwise it is particularly given stated that this is ideal or non-ideal, you will take all the given gases, all the taken gases ideal. Now friends, fourth point is ideal gas equation. Ideal gas equation. Here we are not going to derive this ideal gas equation. This is PV is equal to nRT. This is PV is equal to nRT. Here this P is pressure of the gas, here V is volume, and here this N is number of moles. This is number of moles of gas. This is called universal gas constant, UGC. This is universal gas constant, and friends, this is absolute temperature, or you can say Kelvin temperature. This is the temperature in terms of the Kelvin or the absolute temperature. So PV is equal to nRT. This is ideal gas equation where this P is pressure, this V volume, and this N is number of moles, R is UGC, universal gas constant, and this T is Kelvin temperature. Now friends, we have to take the temperature only in the Kelvin, and Kelvin temperature, this is equal to degree Celsius temperature plus 273. Dear friends, because you are 11th class student, this is simply the introduction of the subject. That's why I am writing each and everything. So the Kelvin temperature in terms of the Kelvin, this is the degree Celsius temperature, and degree Celsius temperature plus 273. Although we will describe this in this relation between the degree Celsius and Kelvin in the gaseous state chapter. So we will study in detail it in the gaseous state chapter, the 6th point. Here friends, we will talk about the pressure, the units of the pressure. Here the one unit of the pressure is 1 atmosphere. Normally this is called 180 MP or 180 M. This is equal to 1.01325 into 10 to the power 5 Pascal. Dear friends, this is the SI unit, Pascal. We can say Pascal as PA, and this is the SI unit. This is SI unit. This atmosphere is not SI unit. This atmosphere is not SI unit. We can say this is 1.01325 bar, and the same is 760 millimeter of the mercury pressure, and 760 millimeter, and here this is 76 centimeter of the mercury pressure. Actually friends, the millimeter and the centimeter, this is the height in the barometric column. So we will discuss this. This will also be discussed in the gaseous state chapter, states of matter chapter. We will discuss it again. There is no any problem. So here you have to compromise little. After talking this, we have to talk even about the, here we talk about the temperature, the units of the temperature, here the units of the pressure, and the 7th point we will talk about the unit of the volume. 1 liter, this is 1 cubic decimeter. This is 1 cubic decimeter. You have to remember this. And 1 milliliter, this is 1 cubic centimeter. 1 cubic centimeter, this is cubic centimeter. So you have to keep in your mind. And 1000 liter, this is 1 cubic meter. This is 1 cubic meter. So all these things you have to keep in your mind. So dear friends, we have also talked about the R. This R was UGC, universal gas constant. Its value 0.0821 liter into atmosphere per mole and per Kelvin. Here we can also say 1/12 liter into atmosphere and per mole and per Kelvin. One more value of the R UGC universal gas constant 8.314 joule per mole per Kelvin. Friends, again here we get the SI unit, and it may be approx value 25.3 joule per mole and per Kelvin. So friends, this is all about the ideal gas equation. We also have to learn something, how to tackle the questions of the ideal gas equation in the next lecture. Thank you very much.